One application of angles that you may remember from your days in geometry, algebra, math classes of the past are similar triangles. Okay, so similar triangles, just by definition, are two triangles where one triangle has angles that correspond to angles in another triangle. So what we would see is that if we have two similar triangles, if we look at the measure of angle A, for instance, in this diagram, that would correspond to angle D. And then similarly, B, whatever that measure is of that angle, would correspond to E. And then C, angle C would correspond to angle F. Okay, so in other words, we have same angles in both triangles. Okay, that doesn't mean that the side lengths are are the same. So we'll talk about that in a moment here. But that's the idea of a similar triangle. Okay, we have matching angles. A consequence of this, I'm going to call the similar triangle property. And so if we have similar triangles, what we can say is that if we look at the side length of one of the sides in the first triangle, let's call this one x. Okay, and if we compare x to, so x would correspond to this side length over here, let's call that m as in Mary. So it says that the side lengths are scalar multiples of one another. So if we looked at x, we would say x is equal to k times m. So we have the two side lengths related by some scalar k. K is just a number. It could be 2, could be 3, could be square root of 5. Okay, we don't know what it is until we find it. Okay, but we would have x, we'd have m, we'd be able to find k from that. Okay, and that's actually what I wanted to mention as a consequence. So if we wanted to find what this value of k was, all we have to do is to take x over m. And so notice that in this case, if we wanted to find this multiple, that would be, side length AB, formal notation is like this, over side length DE. Okay, or really the ratio of any two sides gives us this scalar multiple. Okay, also, I shouldn't use plus, I should use just an and symbol. If we know that we have similar if we have similar triangles, right? We have side ratios being the same. So we could do something like AB over DE. Notation is annoying. And we can, since those two sides are in correspondence, we could do something like Y over N as well. So we would have to keep the side lengths the same in the corresponding triangle. So if we start with the big triangle on top, we have to keep the big triangle side length on top as well. So we could do something like BC over EF and put those into correspondence. And then we have a nice proportion. And so then we have, this would translate to x over m is equal to y over n. And let's say I didn't know what n was. Well, I could do cross products to help me find it. So I could do x times n is equal to y times m, whatever those numbers are, and then solve for n, right? So n is equal to y times m over n. This is just an example. We'll kind of go through some more specifics here in this example. But regardless, the consequence of the similar triangle property is we get proportionality. Okay, so let's use it in the upcoming example. Okay, so we have two triangles. Okay, it says ABC and DEF are right triangles. Okay, so right triangles means that we have a right angle, 90-degree angle. Okay, so we have something like this, and I'm going to make a smaller one. I'm hoping I'm doing this right. So these may not be to scale. So let's see, it says right triangles where C and F are the right angles. We typically put at the vertices, we put the angles. So C, and then it really doesn't matter which one's A, B. I'll do it like this, A, B, and then going kind of following the same order, this would be D and E. The order is important here. Otherwise, it would just be a reflection. Okay, so got a picture. Good. We have right angles, and it says, okay, measure. Okay, this is just telling, this is, again, a little bit of notation. The measure of angle A and the measure of angle D are both pi over 3. Pi over 3. pi over 3. Now, before I go further, I just have to, think, okay, pi over 3. I sometimes have a hard time thinking in radians. So if I wanted to convert that into degrees, remember I just multiply by 180 over pi, and I'd get, pi's would cancel, this would reduce and give me 60 degrees. Okay, so it's 60 degrees. If you want to put that in there, that's fine. Let's see, if the hypotenuse of ABC has length 8, so hypotenuse is the longest side, so that would be side length 8, and DEF has legs that are lengths 2 and 2 square root 3. Okay, so that's, this side and this side, which one goes where? Okay, we need to find the other angles and sides. Okay. Let's leave off labeling those for right now. Okay, I want to find the missing angle. Okay, bonus tidbit is if I want to find the measure of angle B, right? So right now I have C corresponds with F, A corresponds to D, so I almost have similar triangles. B and E should have the same angle measure. What is that? And a little extra tidbit is all angles in a triangle add to 180 degrees, okay, which is also pi radians. All right, so make use of that fact. So if I want to find what angle B is, so I could do like angle B plus a right angle is pi over 2. I'll do the same thing in degrees here in a moment. Plus pi over 3 is equal to pi. If you want to work in degrees, it'd be angle B plus 90 degrees plus 60 degrees is equal to 180 degrees. I'll admit the degree one is going to be easier to work with. So if you, add those, subtract over, you get angle B is 30 degrees. And that actually is the same for angle E. Okay, so there we go. We found one of our answers. Okay, so now we have similar triangles. Great. So we can use proportionality. Great. I still have the problem though. I don't know which is length 2 and which is length 2 square root 3. And the big tip here is, so if we know that this is, let's say 60 degrees and this is 30 degrees, right? The shortest side is across from the shortest angle or smallest angle. Okay, so we have 2 and 2 square root 3. 2 is the smaller of the sides, so that's going to be directly opposite the smallest angle. And similarly, since of the two legs, 2 square root 3 is the larger leg, that's going to be across the larger of the two non-right angles. Okay, so 2 square root 3 goes there. All right, so now I know that these things are proportional because of similarity, right? So if they're similar, I need to figure out what that constant of proportionality is, K, right? Okay, I don't have enough information yet, but I do have another tool from my past that we might have to unearth, the Pythagorean theorem. And, oops, that's an O. Pythagorean theorem. Okay, and you might remember this is C squared is equal to A squared plus B squared. Okay, so C squared is the hypotenuse. Hypotenuse squared is equal to leg squared plus leg squared. Okay, and I'm going to use that fact in triangle DEF. Okay, so I don't know what the hypotenuse is. I'm going to call that C in this case. So I'd have C, technically it would be lowercase f. C squared is equal to 2 squared, which is one leg, plus 2 square root of 3 squared. Okay, if I do the arithmetic here, this would be 4 plus, and this would be 4 times 3, also known as 12. So C squared is equal to 16, square root both sides, and C is equal to plus or minus 4, and I have to do plus or minus because I introduced the radical, but we can't talk about negatives in the context of a triangle, so C is just 4, okay? All right, so we know that this side length is 4. Okay, so if we wanted to label this, this would be length of ED D, and there we go. Okay, we're almost ready to be done. We need to find the other missing side lengths here, so BC and AC. All right. So now this is where I can use similarity. Okay, I know the triangles are similar, so we have. I'm just going to make a note. So I have similar triangles. Okay, so this means I can do, say, the hypotenuse of 1 is equal to, or the hypotenuse of ABC over the hypotenuse of DEF is equal to our constant between them, K. So if I do the arithmetic here, it's just 2 is equal to K. So in other words, to find, to go from triangle DEF, any of those sides, to any of the sides in ABC, I have to multiply by 2, right? 8 is twice of 4, okay? So to get AC, this is going to be 2 times DF, which is 2 times 2, which is 4, okay? And similarly, you can show that EF, or sorry, not EF, BC is equal to 4 square root of 3, okay? Just multiplying 2 squared to 2 by 3, okay? So there we go. We've found all the sides after a while and a lot of extra tools. So when working with triangles, remember you can always make use of these other past formulas as well. Okay. Next one and last example. So a person who is 5 feet 6 inches tall. Okay, so I got to get a person here. Okay, so they're, let's call that 5.5 because I see the other things are all in feet. So let's call this, 5.5. Okay, cast a shadow that is, okay, so here's their shadow, not to scale, that is 1.5 feet. And then a flagpole that is 11 feet. We want to know how much its shadow is. Okay, so how do I do this? Well, let's see if we can see this as a triangle. If I connect the person's head to the tip of the shadow and the top of the flagpole to the tip of the shadow, oh, I have a right triangle. Okay, can I justify that these things are similar? Yeah, actually, right? Since it's the same time of day, whatever this angle from the ground to the top of the pole is will be the same as the angle from the ground to the top of the person because it's the same time of day. And then if you do the arithmetic, you would get that this angle from the top of the person's head down to the ground and the flagpole to the top or to the ground are the same as well. Okay, so I get similar triangles. Okay, so by similar triangles, I can say that these things are in proportion. So 5.5, that height corresponds to a side length of 11 in the big triangle, just as a side length of 1.5 is to x. Okay, now I can use cross products. So 5.5 times x is equal to 1.5 times x. And if I go ahead and solve this, so x is equal to, this is 1.5 times 11, my bad. So it'd be 1.5 times 11 over 5.5. Do that arithmetic and I get 3. Okay, so I've solved the exercise. Now, technically, this is a context exercise, best practice, and something we will be looking for in written homework and, graded, anything that we would grade is a context answer. So a sentence, right? I would say that the length of the flagpole's shadow is 3 feet. Okay, so this exercise, yeah, it's a little nebulous at the beginning, but I think as you get a diagram, right? So start with a diagram, and then In the diagram, look for a triangle and see if you can justify that those triangles you make are similar. If you have similar triangles, set up a proportion, as we did here, solve for the unknown, and then make sure at the end to translate that unknown back into whatever the context is. And you should be good to go. All right. So a little bit of similar triangles. And again, keep in mind these other two side properties, so the Pythagorean theorem and the angle sum property of triangles. And you should be well on your way to being successful in your work with similar triangles and angles.